Hello.
Wait, before we move to example 3, the last part when you were talking about you used one which was
So I can hardly get you.
What is this? You the initial one out. Use the one which fade out. Why didn't you use the initial one? The initial question.
So the question was still initial even at that point, because nothing was changed. So if you have -2 plus x
All right.
to the power -1, they ask for the validity. You cannot say the modulus of x is less than -2. That's not true. The modulus is never less than a negative now. So what we do is in each initial state, we just make sure that we reserve the first position for 1 so that this guy here can be like that. When the power is still outside, we are still having it in its initial state. And then we are now able to find the validity of the expansion. It's just the -2 will go out as a constant.
All right, thank you, sir.
Okay. Okay. Another example. Hello?
Sir, when finding the range of validity, is it always that you say less than 1?
If your first position is 1, you say less than 1.
If it's 4?
Because when it is 4, you have to force it to be 1. So you can still say less than 1.
So you're telling me that it's always it has to be less than 1.
If you've managed to force the first position to be 1, yes.
That's why I'm saying that. So you're telling me that it's always supposed to be less than 1. I have to force the first position to be 1 always.
Yes.
What if I don't know how to force it? Is there another way how I can do it? Because the issue of I failed it.
Okay, so the forcing is mandatory if the first number is negative. But if the first number is positive, you just say this, the second part is less than the first part.
Oh, okay.
Yes.
Okay, thank you, sir.
Okay. So we have this guy here to the power less than half, expand up to and including the term in x3. Solution, you say 3, 1 plus 2 over 3x to the power -half, which is the same as 3 power -half, 1 plus 2 over 3x to the power -half. But this can be written as 1 over √3 if you so wish, 1 plus 2 over 3x. So the expansion keeps this guy outside, and the power is still -half there. So we'll have 1 plus n, which is -half, The b part is 2 over 3x plus n negative half minus 1 over 2. B part is 2 over 3x squared plus negative half minus 1 negative half minus 2 over 3 factorial, which is 3 by 2. The b part is 2 over 3x or 3. You close there. So if your memory is not that good, you must do something to it so that it is able to keep this 1 plus n ax plus n minus 1 over 2 ax squared plus n minus 1 n minus 2 over 3 factorial ax power 3. This is the equation we are using to substitute all these numbers we are substituting here. We just identify the ax part and the n and then substitute throughout. So you know so many four numbers. If you delete one from the head, it can get this, that space can be occupied by this expansion. Or you forget some birthday. So you have 1 over root 3, open. Then you have 1. The first one will give us minus 1 over 3x plus we have negative half minus 1 is negative 3 over 2. 2 over 3 squared is 4 over 9. X squared, we have over 2 plus negative half minus 1 is negative 3 over 2, which is then negative 5 over 2 over 6. That's okay, we can keep it in this form. And then 8 over 27 x power 3. Keep going like that. Then you say 3 can go in 3. 2 can go in 8, 4 times. 2 by 2 is 4, which can take away that 4. 2 can go in 4 twice. So this 2 and that 2 will go. 3 once, 3 in 9, 3. Then we come down and write what has remained. Root 3. 1 minus 1 over 3x. Negative half multiplied by negative 1 multiplied by 1 over 3. That is going to be positive 1 over 6 x squared. And then negative, we'll have negative 5 over 2 times 27, that is 54 x power 3. The expansion ends here. Then they say, okay.
So I have a question.
Sorry, sir. Where did you find the 50? Sorry, sir. The 27 that you multiplied with 3. Where did you get the 3 again?
Where did we get the 3
The
that
last
has?
part.
So I've said
by 27. Yes,
2 by
you're
27.
5 over 54.
Yes.
27. Yeah, that's a number I'm looking for. Where did you get it?
The 2 from here.
Oh, okay. I've seen it. All right, thank you.
So you mean that if you don't factorize the 3, it means that there is how they'll consider the answer, or it is just one and the same, even that one is very correct?
It is one and the same, except that, you know, look, this number, if you don't factor this number out, what you'll be dealing with is 3 plus 2x to the power negative half. We are saying, if you expand this, you have 3 to the power negative 1 over 2 as your first term, plus 3 to the power negative 1 over 2 minus 1 multiplied by 2x plus, in fact, as you are doing that,
no, sir, I'm not getting this what you're
f.
writing down.
Okay, stop. If you don't factor out the 3, you're going to have this thing 100 right here, which is complicated. But your answer, in whichever form it will look like, will be correct. Except that for you to call it the answer, even you yourself, you won't be happy with what you'll be seeing. How come root 3? When the power is half, it's the same as root. So have I answered the question of if we don't factor out the 3?
Yes, but I'm still confused.
So I wanted to deliberately attempt to answer it without factoring out the 3. And you said that's thing I can't get.
I wasn't understanding because we were doing the power, which is negative 1 over 2 minus 1, not the same 3. I don't know, not understanding.
No, the 3 is not the power, is it?
Yes.
So it cannot go in the position of the power. Remember, the expansion we are dealing with is a plus b to the power n, where in your expansion, each of them has a place to occupy. A n minus 1 b, n minus 1 over 2 a n minus 2 b2, n minus 1 n minus 2 over 3 factorial a n minus 3 b3. Okay.
Oh, this is when I've seen it. Okay. Okay. Thank you.
So if you don't factor out the 3, you have work because your a won't be 1. It will be 3. So you must know what 3 to the power negative half is. In each position, you must know what a to that power is. So it will be 3 to the negative powers.
Okay.
So that's the reason why we have said this expansion is not nice as compared to this one. If I have something like this, my life is not complicated in this case because I'm just doing this. My eyes are on the B part and the power. This thing. So it becomes, you're not even worried about the first part because it's just 1. I don't need to know the power of 1. whatever power it is, I'll still get 1. So I concentrate on the B part. That's the
Okay,
beauty
thank
of
you.
doing that. Okay, so if we said, so just before you go for the other course, physics, how do we answer the range of validity question if it comes in this case? A range of validity. You would say the modulus of 2x is less than 3. What is another way of doing it if I can't force a 1? This is another way. For as long as that 3 there is positive as it is, then you can say the modulus of 2x is less than 3. Take away 2, divide it. So you'd get the modulus of x is less than 3/2. Simplified. This is another way. Okay, let's join for physics. Have a good day.